All right, in this video, we're going to look at finding observed values given an area under a normal curve. So again, just the inverse or opposite of what we looked at in the last video. So once again, as I mentioned, it's just the inverse of what we did in the last example. In the last group of problems, we looked at calculating the area, knowing the observed value, mean, and standard deviation. This time, we're going to calculate what the observed value is, knowing the mean and standard deviation, but also the area as well, whether it's left, right, between, or outside. Again, we'll use the technology that we've been using, and most statistical technology has the ability to solve problems like these without the need to convert back from z-scores first. So if you wanted to, you could get what the z-score is, much like we did when we found z-scores for a known area at the end of the last section, and then convert them back with the mean and standard deviation to the observed values. But again, since most technology allows us to solve the problems like these in one step, we'll do that instead. So in example 2, we have our air conditioning manufacturers, and they're saying that their mean is 10,000 BTUs and the standard deviation is 400 BTUs. How many BTUs must a unit have to be in the 90th percentile? So again, the 90th percentile means that 90% of the units, the other units, have less BTUs than the value that we're trying to find. So what we're trying to find is, if we have 90% of all the other values to the left of this particular value, what is that particular value? So again, sketching this, and again, this is computer generated, but a sketch, as long as you have it with shaded to the left, is 0.9. It should help you out in knowing exactly what to put into whatever technology you're using. So let's go ahead and calculate this. This time we are again working with observed values, so option 2. And then we are given an area. In this case, we're given the 0.9 area, 90th percentile, 0.9 is a decimal. So select option 2. Population mean is 10,000. And standard deviation is 400. And we have the area that is to the left, which again, the sketch really should help you out, making sure you select the right one. If you select the wrong one, it's not going to give you the answer in all likelihood. So option 1. And the area that is to the left, we said is 90% is 0.9. And we have 10,512.621. So what that means is that an air conditioning unit with about 10,512 or 10,513 BTUs is going to be in the 90th percentile. So 90% of the other air conditioning units that are manufactured are going to have BTUs that are less than 10,512. All right, part B, an air conditioning unit will not be shipped if it's in either the bottom 0.25% or the top 0.25% of BTUs. So what are those cutoff values? So if we look at our sketch, this red, we'll call it the rejection region here. This red region represents values that are going to get rejected. So if we have a value that's in this red region, it's too low of a BTU to really be effective. If we have one that's above, it might be too effective, maybe cost the customer more money in their energy use. So we're not going to ship out and sell any ones that are in these rejection regions. So we want to know what the values are. How many BTUs does something have to have before it gets rejected? So one way of doing this, which will be the way that we look at in here, is the program we've been using has the ability, just as it did with z-scores, to calculate these observed values directly by knowing the total area. You could also calculate the middle. Let's see, it's 0.25% plus 0.25% is 0.5%. We could also calculate the middle 99.5% and get that as well. So maybe we'll do it both ways just to show you, and we'll be good to go. So, all right, so once again, we are dealing with observed values, so option 2. And we are given an area and need to find the value, so 2 again. Population mean is 10,000. Standard deviation is 400. And we are looking for the area outside the 2 values that we're looking for. So we want 4. Now the total area, I went and updated the code for this whole program because now we can just convert these to decimals and then add them up without having to do it separately. So this is 0.0025 and 0.0025. And rather than add them separately and then type that number into here, we could convert them as we did, 0.0025, and add it to another 0.0025. And this will automatically evaluate this as 0.005 and give us our answer, which in this case is 8,877 and 11,122. So we have 8,877 and about 11,122. So an air conditioning unit will not be shipped if it falls, or if it's outside, not between, outside, sorry about that typo here, outside the values of 8877 and 11,123 BTUs. Now again, looking at it the other way, we could have, we'll go observe value here, and then given an area, option 2, and then enter the population mean, 10,000, and standard deviation 400. And this time we could calculate the area between the two values, so option 3. And then that one we said 99.5% were between, so 99.5% as a decimal is 0.995. And notice we get the exact same values. So these are our cutoff values again, which will mean that anyone in 8877 and 11,122, anything above that 11,122 or below the 8,877 is not going to get shipped. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.